Hey everybody, this is Donnie, and I just thought I would make a smaller, simpler, as you can read, quick introduction to methods to complement the larger, more all-encompassing review of everything that you can do with methods, all the different permutations as far as return values, parameters, different signatures. I thought, when I was looking at it, that it was kind of overwhelming, so I thought it might be useful to start with something pretty simple that covered the very core aspects of methods, such that the more all-encompassing code and presentation and video that goes along with it will be easier to digest once we've kind of just gotten the really core stuff out of the way and focused on it. So let's see if this will help. Um, in the past, obviously, we started the class in the first half with variables that were stateful, and when I say stateful, I just mean that they contain a value that persists. X equals 5, x contains the value of 5 in the variable, and that doesn't go away until the scope ends. Um, and in the past, this wasn't really object-oriented programming because as I said, object-oriented programming relies on the concept that everything has context. Everything happens within the context of an object or a class. Things don't just exist. Things are attributes of something. So, you would look at this code x equals 5, and it's like, where is x? What does x mean? What is x describing? What is this 5? And there's no answer to that here. It's clear. So when we move into object-oriented programming, we get into these concepts here. The most important of them being that we have context and it's stateful. So it's pretty intuitive. We've talked about this before. Any object is stateful. For example, I have red hair and blue eyes, so that's part of my state. The current state of my hair color is red. But that could change. My hair will eventually turn gray, and that's, you know, I'm the object, and I remain here, and I continue to hold the states that I have, but the values of those states may change. A fancy word we use for that is mutate. So if you hear state mutation, it just means changing the values inside of an object. So basically, as at some point when I've decided now my hair is better described as gray, I would say that my state has mutated. So it's as simple as that. It's really just values that are part of an object, and that's the way all values are in object-oriented programming. They're always either on an object or a class. So we've gone over that. Um, I'm going to touch upon a few things that we might not have talked about, like access control, which would just be public versus private. Encapsulation, we have talked about a little bit the idea of, trying to make as much stuff private as possible to simplify the use of the object, try to minimize the public API as that third part. I kind of give you the microwave example where, it's a very complex object, but you want to make it easy to use um, for, by putting just a few buttons on the front that you can push. Uh, so you don't really need to understand how it works. You just need to be able to make it work. Um, and that also plays into the whole method signature, right? Um, so we originally learned this as functions, but now we're learning this as methods. The only difference between functions, outside of object-oriented programming and methods in object-oriented programming is that methods have context. So we're adding this idea of something is doing this method. It's not just a function that's doing mathematical calculations. Something is actually something stateful. An object is performing the method. So I'll use the word method from now on instead of function. So the third point I have there before I move on and just look at the code is method scope. And what that means is basically like, what can you see when you're defining a method? And this is like, a little bullet list that I'm going to go through. And I'm not going to read through this right now because it'll be apparent as we go through the code. And I want to make this video pretty short. So I just whipped up a really simple class with not all, but the most basic and integral parts of method concepts. Create a person with three variables. One of them is a public constant, so that is basically a public static. So person dot minimum voting age equals 18 just means that uh, anywhere in the code you can always say person dot minimum voting age, and that basically is replaced by the number 18. So that's pretty simple. And then this just says, I put this here as just a contrast. We don't really want to do this. As I said in the last lecture, we pretty much want to make every member variable private if possible, but I did put this here as a contrast. We have a public string name, and then in contrast to that, public int age, which is the better and proper way to do it. So this constitutes these two variables constitute the state of any given person. So if you create a bunch of people, each one of them is going to have a current name and a current age, and that is their state. And sometimes we say immutable and immutable. We're never going to be working with, well, aside from the constants, a constant is immutable. You can't change it. But for the most part, every single variable that we're using is mutable, which means you can change the value anytime you want. So even though it's stateful and it has current values, you could always change them. That's what we've been doing all along with the assignment operator. Has been mutating the value of a variable. Um, I'm just preparing you to be able to hear language that more advanced programmers use that actually aren't as fancy as they sound. Like mutating state is really just setting a value inside of an object. Programmers like to sound smarter than they really are. so so we get to these two first, and this is the very basic. Usually the first two things you learn, especially in Java. This is a pattern. A pattern, just in case you don't know, a pattern, the word pattern means something is widely used in all of the industry. Like you could go to any company and work, and you'll recognize this pattern. This is called the get set pattern. It's really good to start with actually as a learning exercise because um, as you can see, one of the return values on getAge is an integer, which is not void. And then the other one, setAge, is return value of a void. So this is kind of the perfect example of why we call these methods and not functions. Because an actual function would take a value and return a value, and neither of these do that. The first one doesn't, getAge doesn't take a value, and setAge doesn't return a value. So let's talk about these really quick. The purpose of get age. So if you look at the signature, it says, and remember, you want to think of this every single method definition as something you are asking an object to do, and the return value is if after the object is done doing what you ask it to do, if there's some type of value that you need it to come back with, that's what it will give you. Depending on what you tell it to do, it might have a return value. So if I tell somebody like, hey, go to Chipotle and get me a burrito, I'm going to sit there and wait for them to bring me back the burrito. But if I tell somebody, hey, go drive over to Cincinnati, that's it. I just tell them to do it and then I walk away and I'm not waiting for them. So that's the difference between, something that has an actual return value and something that doesn't. And as far as the parameters, that would be like just when I'm performing the question to ask the object to do something, does it need more information? Like for example, if I say, like, hey, you, um, how old are you? That's just a simple question, and that's exactly what this method I've highlighted is. It doesn't need parameters because it's a simple question, and the object that I'm asking the question of has all of the information it needs internally to answer it. So that kind of goes back up to here. Uh, the object has access to any information about itself, obviously. It's like I know everything about myself. If you ask me how old I am, I can tell you that without you, giving me any type of external information. Um, on the other hand, the second method, uh, somebody says basically is telling me they want to change my age. And obviously you can't do that in real life, but in a program you can. You can say, hey, this object is now a different age. Okay, well you can't just say that. You can't just say like, your age is now changed, because that's not sufficient to be able to complete the task. Uh, The, conceptually, the object would say, okay, you want me to change my age. Well, what do you want me to change it to? And that's where the parameter comes in. So whereas the concept of the return value is, you're waiting for the method to complete its task and waiting for it to bring you back something. Um, in this case, this is more of what I said before, like, hey, go drive to Cincinnati, and then I walk away. I'm just telling it to do something. So a void method is basically means I'm telling it to do something, and I'm not waiting for it to give me anything back. Um, the trick to this is there's kind of two types of void methods, and this is one of the debated problems of object-oriented programming, is that you don't actually know by looking at the signature if a void method is uh, mutating the state of the object. Hopefully, if people follow the right patterns and name things correctly, if you say set age, that's clearly intended to mutate the state of the object. It's changing the object. You're changing the age of the person. You're saying, hey object, I want you to change your age, and here's the age. Here's your new age. You used to be 18, but now you're 19. So that is clearly I'm just telling you to do something. I'm telling you to change your state, and that's it. That's it. I'm just telling you to change. There are some void methods that don't mutate the state, and that's argued by some people as a flaw of object-oriented programming, because you don't really know unless you examine the body of the method what it's doing. You can trust the signature, but it is possible to write a void method that changes values, but it's also possible to write a void method that does not change any values. Obviously, you could have a void method, called set whatever, that has absolutely no code in the body, like this. That would work perfectly fine. That's a method that does absolutely nothing, so that would mutate any state. Um, So that's kind of one of the interesting points of methods is whether or not they're changing the object. Um, I would say in general, if you're doing things I'm gonna go ahead and say the right way, void methods are generally used to change state, to mutate state. Not always, but almost, usually void methods are used to alter the state of um, the object that they are attached to. And usually, non-void methods are used to just compute something, or basically give it right back. Um, this would be the case of just give something right back, like here, I need to know the age, which is kind of internal to the object. And here's another example that has a parameter. So this says um, get age incremented by, but it also gives years. So like I said before, if you went to an object and you said, hey, I want you to tell me how old you are, but incremented by a certain number of years, the object would obviously reply, well, what do how many years do you want me to increment it by? So it's not something that you can do without providing this parameter years. So it will give you back whatever your age is plus a certain amount of years. This is probably the culmination and most interesting method that I put in here. Um, I just decided to put in an if statement just to show a little bit of what even a method with no parameters has access to. So in this case, I'm referring inside of the method body to something that is neither a member variable or a parameter. So, up here I have a little list, like what can you get at from inside of a method? Well, obviously anything that's part of the method or anything that's part of the object. So if you're asking me as Donnie as an object, to tell you my age, I can do that. So I have access to that information. If you tell me that you want me to say something and then tell me and pass as a parameter the thing you want me to say, like if you say, hey Donnie, I want you to say something. Well, I'm like, well, what do you want me to say? And you say, well, I want you to say hello. that would be the parameter. So I can do that. So I have access to my own information, my stateful information, and I have access to any parameters that you require with the action you're asking me to perform. This one should be obvious. If you declare any local variables, like if you said like int x at the top of the method body, it would be gone at the end of the method body. But this is pretty much ubiquitous across all, and not just methods, but all anywhere where you see a begin and an end curly brace. If you declare a local variable, you have access to it for the rest of the scope until you see the end curly brace that coincides with the first one, the begin. And this example I was showing you is this last one. Anything public and static. Um, so this value right here, person.min voting age, if you look at the top here, it's public const, which is basically public static min voting age. So you can access that from literally anywhere. It's pretty much a global variable that anything can access. So this is a computed value. It's something that I'm not giving any if I'm saying like, hey, you, how many years until you can vote? They don't need to ask me like, for more information. They can simply answer the question. So if I ask a 15-year-old, hey, how many years until you can vote? They would simply answer 3, with me not providing them with any more information, because that is it's based on something that's not necessarily part of them, but it's something that they know of. So this min voting age that's public static is kind of like information that's just known by everyone. It's not a part of them personally, but it is known information, so you don't need a parameter. So these are kind of like just the concepts of these methods. Like, is it void or is it non-void? Well, are you expecting a value back? Does it have parameters or does it not have parameters? Well, do you need to give it any information that it needs to complete the task you're asking it to perform? So this is, I'm trying to, explain the different variations of methods in an intuitive, real life way. So in this case, if I ask somebody how many years until you can vote, they can answer that just based on public knowledge and knowledge of their own age. So they're using a combination of the knowledge of themselves, how old they are, and the public knowledge of what the minimum voting age is. So based on that, we can basically compute how many years until they can vote. And finally, here is an example of a void method that does not mutate anything. It does not change any values. It simply does something. Um, it just does something, and it doesn't return anything. Like this returns something, which can be seen right here. We're using the value that it returns. We're saying if that method that computes whether or not, or how many years there are until you can vote, we use that value, which is an integer, to decide what the output should look like. Um, this method here, literally all it does is print this to the screen. So that's not changing the state of any object. It's not returning any value. It's simply printing this information to the screen. And that's pretty much it. So I have here an example of how we could use a public variable to access the value of it, but really the proper way to do it is to encapsulate the value like we do with age and get it by calling a public method. In general, that's a very general overview of the very basic types of methods. So just by pondering the get set pattern and how those two differ, and pondering what I said about making the analogies to real life, asking somebody to do something, whether or not they're going to come back with a value, whether or not they need more information to complete the task. Anyway, for now, I hope this will give you some stuff to think about and practice, and for now, I hope this helps. All right, happy Veterans Day. Oh, it's 12:02 a.m. It's officially Veterans Day. Happy Veterans Day, and I will talk to you guys 1 week from tomorrow, but you'll hear from me before that. All right, bye.